We're live.
Hello, everyone, and welcome to this new episode of the Tech Cafe podcast. My name is Khaled ElNaggar, and I will be your host for today. Today's episode is all about TDD. I'd like to welcome Ahmed Misbah, Tech Cafe's founder, who will join me today to talk about his experience in TDD and answer our questions on the topic. Welcome to this episode, Ahmed.
Thank you very much, Khaled.
To our dear attendees, feel free to ask any questions in the chat, and we will be more than happy to answer them at the end of today's session. Also, stay tuned as we will make very important announcements at the end of the session with very special offers. Ahmed, tell us about your story. When did you learn about TDD and start practicing it?
I started practicing TDD very early in my career, like 16 years ago in 2007. I was outsourced to a startup company based in Europe to build a very interesting social network related to stocks. The team was composed of very experienced developers, and they were using this agile methodology called extreme programming. Now, to me, extreme programming and agile was something I've never heard of at the time. When we studied software engineering 2 years before that in university, the closest thing we have heard of to extreme programming was incremental and iterative development. But we have never heard about extreme programming's core practices like test-driven development, continuous integration, small increments, user stories, etc. Now, this team was doing most of the core practices of extreme programming. And one of the notable practices they weren't doing was pair programming. But they did do very thorough code reviews. TDD was practiced only at the level of the back end. So this was supposed to be a web application. And so you had the client-side code that was going to run on the browser, and you had the server-side code or the back end, which was basically a Java application. And we practiced TDD against that application. The end-to-end testing was performed by a QA engineer and was done manually. Automation testing at the level of the browser was not yet a very popular thing back then. Of course, we're talking about something that happened in 2007, so that was a long time ago. So unfortunately, because of the absence of mentoring and pair programming, and the reason why, or one of the reasons why we didn't do pair programming was that I was based in Cairo and the team was based in Luxembourg, and we didn't have all these fancy tools we have today, Zoom, Teams, etc. And so it was very hard to do pair programming the way we can do it right now in a remote setup or where different team members are co-located in different places. So because of the absence of mentoring and pair programming, I did not practice TDD the right way. I was doing test last development. So this is where I first wrote the production code, then I wrote automated tests for that, which is not really TDD. I was only doing red-green cycles, so not following the red-green refactor mantra. So I totally neglected the refactor phase and was just doing red-green cycles. So basically writing the code, then writing tests, and then writing more code, writing more tests, etc. There was no refactoring. So when that project was over, I joined another company, and that company was highly driven by the concepts of the fifth discipline book. The company promoted collaboration, knowledge sharing, learning, coding katas, etc., which made a very big difference in my TDD experience. I finally started recognizing the value of working with test first. But the refactoring part was not yet clear to me. When I joined my fourth employer, that was an entity that was part of a very big corporate. And as part of their software development process, they did very strict code quality audits approaching the end of every project or every milestone in a project. So we called those stabilization sprints. So the code would be audited. There will be all sorts of problems with the code that obviously needed refactoring. And that stabilization sprint would be fully dedicated to refactoring the code. And of course, every time you would refactor, you had to test the code to make sure that you didn't break anything. This is when I started recognizing the value of the refactoring phase in TDD. I also started recognizing that TDD was not a test strategy, but it was a development and design technique that is all about design done incrementally and code being refactored continuously so that we would prevent all of that big refactoring that had to be done during stabilization sprints. And this is when I came to learn why many mature agile teams didn't really need to have stabilization sprints, because they were basically doing refactoring all the time. And so their code was always stable. I mean, why would you deliver unstable code and then have to stabilize that code at the last sprint of a release if you're doing Scrum, of course? So today I cannot write any code without doing TDD. Even if I'm learning a new library or framework or whatever, I write learning tests, and this is the way I code. And it's TDD is a practice and a discipline to me, and I like keeping it, and I enjoy doing it.
So you don't only practice TDD for your day-to-day job, you also do it for toy projects and for new frameworks and languages that you try to learn.
Yes, exactly. And the reason why I do so is that if I want to remember what I was doing, I can refer back to the tests, okay? Because one of the benefits you get with writing tests is that tests document your code, and they basically tell you what that piece of code is supposed to be doing. And it tests that. It makes sure that the code is actually doing what it's supposed to do. And when you're working with a team and the team decided that you're going to learn some new technology and then come back with that experience, if you have written tests, then people can refer to the tests and start understanding how to use the library or the new technology from the tests. Okay, so yeah, it's right. Now, I know that many people would argue and say that you don't have to do TDD when you are doing toy projects or spikes or whatever, okay? Because you're going to throw that away and then use the experience to write production code. I disagree with that. Now, you don't have to do the thorough testing you do with production code, because obviously you're not testing the library. It has already been tested. but the tests are guiding you in using the library, and they're acting as documentation later on for you to know that, if I want to use this library or piece of technology to do this, then I can refer back to that test and see how I can do it. So I think this is part of what makes learning tests a very important pattern in TDD.
Wow, what a journey learning TDD. It's interesting that you mentioned practicing test last, then red-green only at the beginning. Can you tell us more about red-green?
Certainly. So red-green is when you write a failing test, then write code to make the test pass. It totally ignores the refactor phase, and that is actually not the right way to do TDD. So if you want to do TDD correctly, you should at least follow the red-green refactor mantra that was invented by Kent Beck. So you should write a failing test, then you should write just enough code to make the test pass, then you should refactor the code until you're satisfied with its quality, and then move to another test. So this is the right way of doing TDD. So if you skip the refactor phase, according to Martin Fowler, this is one of the ways you can screw up TDD. And you learn from experience practicing the third phase, the refactor phase, that TDD is a development and design approach, and that design in TDD is both inverted and distributed, as stated in Industrial Logic's Test-Driven Development e-learning album. So in the classical software development lifecycle, you first start with upfront design, then you code, then you test what you have coded, and then maybe later on you will refactor. In TDD, things are a little bit different. You start with a test, you write code to satisfy the test, and then you start thinking about design in the refactor phase. So it's inverted because it comes at the end of the cycle and not at the beginning of the cycle, as is the case in classical software development lifecycle. And it is distributed because the design incrementally evolves in every red-green refactor cycle. Long story short, red-green is simply a TDD anti-pattern. It's definitely not the right way to do TDD. And I forgot to mention that, referring to this interesting graph in one of Robert Martin's articles, the graph clearly illustrates what you get when you don't do incremental and evolutionary design. Okay, so in terms of developing and delivering functionality, maybe you will be a little bit faster at the beginning than when you're doing TDD or you're doing evolutionary or incremental design. But then at a certain point, your productivity starts going down, not doing continuous refactoring and continuous design, as opposed to having a linear productivity or a steady rate of productivity, but you're delivering more features. So it's accumulating. Okay, you're delivering more features over time. this is the bad thing about not doing refactoring and continuous design. Eventually, you start delivering less functionality, your productivity starts going low. And that is due to the fact that you start accumulating what is known as technical debt. And yeah, over time, technical debt keeps on accumulating, and it keeps on reducing your throughput, reducing your productivity, until you come to a point where you reach to a default. You simply can't pay back the debt, and you have to do a big revamp or something. And the cost of change in the code starts becoming too high that business loses confidence in the development team and basically says, I'm not going to ask for more features. It's just going to take forever. So yeah, that's the importance of refactoring. And that's why just doing red-green cycles is simply a TDD anti-pattern.
I like that an analogy, Ahmed, with the technical debt. What about test class development? Can you tell us about it?
Surely. So test class development is recognized by 𝗵𝗵𝗶𝗀𝗍 in his book Agile Adoption Patterns as one of the approaches for doing developer testing or developer tests. To me, it is just waterfall development. What's test class development all about? It's about writing the production code first and then writing automated tests to test that code. So as I said, it's just waterfall development, and it's basically another TDD anti-pattern. Now, why do I think it's a TDD anti-pattern? It's because it breaks a lot of TDD principles. So let's start with the 3 laws of TDD. The first law states that you may not write production code until you have written a failing unit test. So when you're doing test class development, you're basically breaking that law, which is a very important law in basically the TDD principles. So if you're not following principles, then basically you're following an anti-pattern. And referring to the first properties of unit testing, one of these properties is that unit tests should be timely, meaning that they should be written before the production code. So if you write tests after writing the production code, then it's simply not the right way to do TDD. And Tim Otter, in one of his articles, and I think it was co-authored with Jeff Langer, stated many reasons why test after isn't good enough. And I think you can see in the slide, he argues that it is undisciplined, falls victim to ego, appears unnecessary. So these are just, one of or a couple of reasons why it is just doesn't work. So yeah, it is an anti-pattern, and yeah, the right way to do TDD is to follow a test first approach.
From what you've just said, there seems to be many ways to get TDD wrongly. Can you tell us about TDD anti-patterns, Ahmed?
Sure thing. So if you Google TDD anti-patterns, you will get so many articles regarding this topic. And I'm just gonna mention 2. So there's the list by Tim Otter, and it contains many anti-patterns. So one of them is the liar anti-pattern, meaning that the test is not really testing what is supposed to be testing. So that is one of the anti-patterns, and it is a very common anti-pattern. And there is the giant anti-pattern. This is where the test method is so huge and lacks cohesion. It's basically testing so many things at the same time. And this breaks two best practices that Robert Martin has stated in the Clean Code book. So it breaks the concept of single concept per test and one assertion per test, okay? Because when you have a giant test, basically you're testing many concepts, plus you are definitely not going to be having one assertion. And here's the thing, test code is code, and you want it to be so small so that you wouldn't have to worry about its maintainability. Otherwise, people, laugh about this and say, we'll have to write tests to test the tests. And this makes, no sense at all. There's also my list, which I have presented in many sessions previously and events. So I state 7 anti-patterns, and you can check the videos for this session on my YouTube channel. And we'll probably do this session again in November, inshallah. So the 7 anti-patterns are having no test list, not doing any refactoring or skipping the refactor phase, not doing collaborative programming, not following a particular school, or at least not knowing about the schools, not doing integration, not doing mutation testing, and jumping into practice and learning the technologies before learning the theory. So this is my list of anti-patterns, and it's really based on my years of experience practicing TDD. So yeah, there you have it, the TDD anti-patterns.
Yes, there are definitely many ways to get TDD wrongly, and there are definitely many TDD anti-patterns. Also, going back to your experience with teams that were going through different stages of adopting and learning TDD, how do you think teams can best start learning TDD, Ahmed?
That's a very good question, Khaled, and thank you for that question. So I've posted a few months ago an article on LinkedIn with a proposed adoption plan, or we can call it also a learning path or a learning plan for TDD. So let's have a look at that. So there is, a list of, I wouldn't say recommended readings, I'd say readings that you must do before you start practicing TDD. So you have to master the programming paradigm you plan to write code with, and master one programming language with that paradigm. And then you need to start reading the books that you see in front of you right now. And I know that many of these books are a little bit object-oriented design kind of books, but I think that object-oriented design is a very popular programming paradigm, and most of the people I know and most of the projects I've seen, they use that programming paradigm. So Clean Code book by Robert Martin, Refactoring by Martin Fowler, Refactoring to Patterns for Joshua Krivyaski, Working Effectively with Legacy Code for Michael Feathers, and Design Patterns for Gang of Four, Gamma et al. These are books that you must read. And the reason why I think you must read these books is that when you start doing the refactor phase, you are going to start, you will need to know where are the code smells? What principles should I start applying? What design patterns? What am I doing wrong with this code? And you can't do that unless you know what all of this is about. And the books you see in front of you right now are excellent source to start learning this. So if you don't read these books and many other books, the refactor phase is going to go really wrong with you. So once you finish that, you will want to understand the basics. So test-driven development by example by Kent Beck is an excellent place to start. The Three Laws of TDD by Robert Martin in Clean Code book. First properties, also explained in the Clean Code book by Robert Martin. Test desiderata by Kent Beck. There's a GitHub page for that and corresponding videos for each principle, the TDD manifesto. And if you want to get really good at writing tests, you may want to read Effective Software Testing, a Developer's Guide. Now, I would like to argue that developers need to learn a lot about testing. And yeah, we say that TDD is all about development and design, but you still have to write tests and you still have to have good test coverage. So developers need to learn a little about testing, and I think that the second item or the second book in this list is a very good book to read, and it has recently been published, so it's not an old book. Then you have to start, going beyond the basics. So once you have understood the basics and the theory, you will want to learn a piece of technology, library, or whatever to start using for practicing TDD. And that doesn't only include test libraries, like, for example, JUnit and Jest and all sorts of libraries. No, I also mean the libraries for mocking, for generating test data, for advanced assertions, for doing mutation testing, etc., for doing code coverage, measuring code coverage. So you will want to start learning some technologies, okay, to start practicing what you've learned earlier. Then you need to learn about the anti-patterns so that you wouldn't practice the anti-patterns, or so that you would be able to recognize the anti-patterns. And of course, you can read Tim Otter's anti-patterns, or perhaps watch my videos that explain my list of anti-patterns. Okay, so you've learned the basics with a little bit of practicing. You've learned the technologies. Now you want to get your hands dirty. So start practicing on greenfield project katas, okay? Don't jump into practicing TDD in a real project. You're putting that real project at risk of falling victim to you still, trying to figure things out in TDD. My recommendation, and I may be wrong, but this is what I've learned from experience, start first practicing on katas, and then once you've built enough muscle, start practicing on real projects. And some of the good sources to get katas from is the Coding Dojo handbook or the codingdojo.org website. They have really good katas. And I think that coding katas should be something every software professional and every software team should be doing at least an hour or two every week or every sprint. Now, I know that some people like to practice competitive programming, and they like entering competitions and stuff like that, thinking that this is the only way to, get better at writing code. But what about coding katas? Okay, if you want to learn about extreme programming practices or software engineering practices in general, competitive programming exercises are not the right tool for that. Okay, I think that coding katas are meant for that. So if you're a team that promotes continuous learning and you're an organization that promotes a culture of learning, reserve an hour or two every week or every sprint for the team to start practicing different extreme programming practices on coding katas. Okay, now once you're done with a couple of katas that are greenfield, start practicing on brownfield katas or legacy code katas to get your hands dirty with how to practice TDD on legacy code. Once you've done that, maybe you can start learning about test, commit, revert and microtests or microtesting. These are really good techniques when working with in the brownfield or with legacy code. Then after that, spike TDD in a real project. Perhaps you need to, start getting the boilerplate code ready, some frameworks that need to be built, etc., on the real project, and then start practicing TDD in a real project. Now, that sounds like a very long adoption plan. Now, I'm not really concerned about how long it would take. I mean, your velocity in that is really up to you. I mean, it can get done in a couple of months, but know this, TDD is not something you will start practicing on a real project in a couple of days or a couple of weeks. No, give it time and make sure that you understand how it's going to be practiced, then start practicing it in a real project. Because, and I've said this before in my session with Tech Excellence, that if TDD does not work in a real project, people are going to start getting skeptical. Your teammates that are resisting the idea are going to say, look, it's failing. Management that are against the idea or don't really get it are going to say, hey, look, this is not working. Let's just stop doing it. Okay, let's get back to classical test last approaches. So you will want to try and make a good first impression. Okay. Yeah, I think this adoption plan is a good way of trying to, get that first good impression.
Yes, that's a very interesting adoption plan, Ahmed, and I like how it incorporates many books and many principles. You start with learning programming first, and then in the basics phase, you start with the theory and practice, and then go beyond the basics. It can't be taught in a setting or in a few hours course, Ahmed. I like how you presented the plan. There's definitely a learning curve to that. But one of the critiques against TDD is that TDD is easy only when practiced in greenfield projects. What tends to be, that is, TDD tends to be challenging with legacy code. Can you tell us about that, Ahmed?
Thank you for that really good question, Khaled. So, a very important question as well. So, many people think that TDD is done differently on legacy code, when in fact, this is not true. You still do red-green refactoring on legacy code, but it's just more challenging and time-consuming, especially in the refactor part, okay, and maybe also in the red part, than when you are practicing it on a greenfield project. And yeah, it keeps on being challenging until the code base incrementally improves and starts becoming easier to maintain. So let's talk a little about legacy code. So the typical tasks you will do in legacy code, and I got those from the legacy code e-learning album from Industrial Logic, and I think they got them from dealing with legacy code by Michael Feathers. they said that the 3 tasks you would typically do on legacy code is add or change some behavior, fix and tweak something, or basically extract code that you would like to reuse elsewhere. So extract some code and expose it as an API or something so that it would be reusable in other parts of your code base. So let's see how we will practice TDD in the first 2 on legacy code. So if you want to add or change some behavior in legacy code, so the product owner or the customer or whoever has asked for some new feature to be added or for some existing feature to be modified. So it's going to go red, green, refactor as usual. So you are going to write a test to test the new behavior. That's the red bar. Then write code to implement the new behavior. That's the green bar. And then once the test goes green, you refactor. And the refactoring part is always the challenging part, okay? And it's not just the refactor. Getting the test to run and fail and then pass may be challenging when it's legacy code because of all the embedded dependencies, etc. So this is the way you do TDD in the first scenario. Second scenario, you want to fix or tweak something. So you have a bug or a defect that you want to fix, or you've got something that needs a little bit of refactoring. So when we say you have a bug that needs to be fixed, this is basically some behavior that was supposed to be implemented and that hasn't been implemented, okay, or wasn't implemented the right way. So it's basically wrong behavior that you want to correct or missing behavior that you want to add. Or it's something you want to optimize. You want to make the code more maintainable. You want to improve its performance, whatever. So you're going to do a little bit of modifications to the structure without affecting the behavior. And that is what we call refactoring. So you're going to, in the case of fixing bugs, you're going to write a test to reproduce the error or the bug. This is the red bar. Then you are going to write code to fix that bug. That is the green bar. And then this is legacy code. So it definitely has a lot of anti-patterns, smells, etc. So you want to refactor that code. Now, approaching legacy code, we need to first understand its properties. So legacy code is hard to understand, hard to change, hard to find defects, hard to fix defects when you find them, and hard to know when you're doing the right thing. So I think the nice thing about writing tests is that it addresses all of these points. Why? Because when you're writing a test, you are writing this or developing this safety net to make sure that you're doing the right thing. And if you're doing TCR, this takes it to a totally new level. And if you're doing continuous refactoring, then you're going to make the code easier to understand, easier to change, easier to find defects, etc. Now, knowing this, when you're doing TDD in legacy code, you have to remember a couple of principles. The first one is Kent Beck's dad quote, make it work, make it right, make it fast. So when you're writing a test, first of all, make the test pass, then refactor, make the production code right, and then optimize this production code for performance. So make it work, make it right, make it fast. We also need to remember that, and this is another quote that was said by Kent Beck, make the change easy, then make the easy change. So yeah, sometimes you have to spend a little bit of effort refactoring in order to make the cost of change much less in the future. And not just that, You want to make the code better so that humans can understand. And this is Martin Fowler's quote. Any fool can write code that a computer can understand. Good programmers write code that humans can understand. So you're doing the refactoring and you're spending effort in the refactoring to make the easy changes in the future and to basically make it work, make it right, and make it fast. And then last but not least, the Boy Scout rule. So Robert Martin was the first to incept this rule, and he actually took it from the Boy Scouts. And he said, always leave the campground cleaner than you found it. And if we're going to map that to software development, he said that check the code in cleaner than you checked it out every single time. So if we're going to use get terminology, so always commit or push the code cleaner than you have pulled it out. And here I would like to say what I always say when I quote Robert Martin's Boy Scout rule. It is not offensive if you change other people's code to make it better. Actually, if you don't do so, it's wrong. You're breaking the Boy Scouts rule. So follow the Boy Scout rule. Refactor the code, make it better. Yes, it's going to be challenging with legacy code, but the effort or the return on investment is worth the effort. And I recommend working effectively with legacy code. It's a really good book. It's going to explain to you the different problems with legacy code and how to address each problem, so that when you start wanting to practice TDD and legacy code and you start meeting all these challenges, from the knowledge you will gain from that book and the examples, you will know how to tackle these challenges.
Thank you, Ahmed. I think the difficulty with dealing with legacy code is the result of what you mentioned earlier as technical debt. Code that's written without TDD lacks the documentation that comes with tests, as well as lacks the incremental design and refactoring. Thank you for providing the ways to deal with legacy code. But going back to TDD anti-patterns, you mentioned not following any school of TDD as an anti-pattern. Can you tell us about the schools of TDD?
Sure thing. So the schools of TDD answer a very important question, and that is, if I have a certain software structure, okay, from which layer or from which component do I start doing or writing tests in that structure? So let's say I'm doing traditional layered architecture, okay, in some monolithic application. And I have a presentation layer, I have a service layer, a business logic layer, and a database layer or a data access layer, okay? So where do I start from? Do I start from the presentation layer? Do I start from the data access layer? Do I start from the business logic layer? Where do I start from? And how do I move forward? So do I go inside out or inside in? What's the right approach? So this is where the the schools of TDD come in. So there are two popular schools of TDD. There's the classicist school, also known as the Chicago School or the Detroit School of TDD. This is an inside-out school. So you start from your core or from your domain, and you start moving to the outer layers. So you write tests for the domain layer first, and then you move to the outer layers. Uh, it tests behavior purely because the domain layer is all about testing behavior. And when you start with the domain layer, then you start building the layers above that, the API layer or the data access layer or whatever. It's all driven by what the domain needs and not the other way around. And the good thing about it is that it does not heavily rely on mocks. In fact, it may not require mocks at all. Yes, you are definitely going to be using some sort of test double. Yeah, sure. But here's the thing. People use mocks and test doubles. They use these terms interchangeably as if they mean the same thing, when in fact, this is not true. Mocks are one of many types of test doubles, and you can refer to XUnit patterns book for that. So maybe you're going to be using stubs or fakes or whatever, but you will not heavily rely on mocks. So this is the first school, and it's a popular school, to be honest. I mean, most Agilists like this school. And then there's the other school, the Mocha school, or it's also known as the London School of TDD. This is an outside-in school. So you start from the top layer, say this is the API layer or the presentation layer, and then you move downwards towards the inner layers. Now, people argue that this school tests structure. And the reason why they say that is that the outer layers usually depend on the inner layers. So if you're going to start coding the outer layers first, in order to make the tests pass, you will need to mock or stub the inner layers that have not yet been implemented. So people argue that it tests structure rather than tests behavior, and it heavily relies on mocks. So these are the schools of TDD, and I'm not going to go into the pros and cons of each school. We can leave that to another session or workshop. And here's the thing. Don't look at it from the perspective of which school is better, okay? Learn both schools, understand them very well, and then as part of your working agreement or your project charter or your coding standards, agree collectively on what approach is better for your project or for your team. Okay, it's as simple as that. Don't just say, no, the classical school is better. Everyone is saying it's good. Let's just do it. No. Do the assessment, understand the schools, and then take an informed decision on which school makes sense for your team and your project or product or whatever. And by the way, some people practice one school and in writing code for some feature, and then they practice another school for another feature. If you are doing pair programming, every pair can choose the school they want to work with. It's perfectly fine. And even if you're doing mobbing, each mob can choose which school to follow. And by the way, you can change schools in every red-green refactor cycle. So it's really up to the team, okay? And it's not a decision that you can't, roll back. No, as I said, you can do a different school in every iteration. It's nothing's going to stop you from that.
Very nice schools and very nice differences between them. But Ahmed, what role do software testers play in TDD?
Okay, so many people think that if we're going to do developer testing and there's going to be all these automated tests and this high test coverage done by the automation, then there's no role for testers in the software development team. This is not accurate. So I'm not going to talk about the role of testers in a software team in general, especially agile software teams, because everyone knows that they can play a role with that. So let's just focus on TDD, which was your question. So yeah, so the red-green refactor mantra is not the only mantra that is around for test-driven development. There's also the think, test, green or code and refactor mantra by James Shore. And okay, so test, code, refactor is basically red-green refactor, and we already know that. So what's the think phase? What happens in the think phase? In the think phase, we can move to another slide, and that is captured from the Coding Dojo handbook. The author of the book doesn't use the term think, she uses the term overview. So this is when you analyze the problem, write a test list, and perhaps prioritize the lists, okay, and start, basically the test list is the things that you want to test. It's your mini plan, okay, for your TDD, for your red-green refactor cycles. So in this phase, testers can play a very active role. If you're doing pair programming, tester can pair with a developer, and they can understand the user story, capture more information on that user story, and start writing a test list from the user story and its acceptance criteria. Moving to the red phase, testers can write the tests, the automated tests in this case, and see the tests go red, I'm sorry, because you have to see the tests fail. And then maybe in the green part, the developers can start coding, or perhaps the testers can write just enough code to make the test pass, and then the developers can take over from the refactor phase, and then the cycle continues. So yeah, if the team is doing some sort of collaborative programming, ensemble, or pairing, testers are going to be part of the pair or part of the team or part of the mob, and they will definitely have a role to play. And I do recommend the approaches I've just mentioned. And Khaled, you and I have worked in the same team, and both you and I know that this is the approach that we follow. We pair with testers all the time to write user stories, to understand the user stories, to write the test list. And yeah, okay, testers then go and write the user tests, and developers continue doing their developer tests, and they pair together, developer. But yeah, we follow this approach, and it works really well with us.
Yes, indeed, Ahmed. I think testers play a critical role in coming up with the test list alongside the developers. This is one of the critical phases of the TDD mantra. In a previous episode of Tech Cafe, you announced a new agile tool called TDD cards of your own making, Ahmed. Can you talk to us about that?
Okay, so the TDD cards is a new agile tool I've invented recently that aims to help agile teams improve their TDD experience. It is basically a card deck consisting of 50 cards split into 7 categories. Those categories are think, red bar patterns, green bar patterns, refactor, integrate, recommended practices, and measure. So these are the 7 categories. Under each category are a number of cards that explains a practice or a pattern or a metric and asks important questions about that practice or pattern. So I've picked 3 cards out of the 50 cards to demonstrate as an example. So I have one card from the red bar patterns, and the card states, or it's about test first, and it says, in test-driven development, tests should be written before the production code. Do you write the tests before the production code? How often do you break this rule and why? So if you're a developer still learning about TDD and you're going through the cards and you pick up this card, it's going to teach you that test-driven development is about test first, and you're going to start understanding how to do tests first from different resources. And if you're a team and perhaps you're in a retrospective or in a learning session or whatever, and you've picked up this card, you're going to ask the question, are we doing test first or are we practicing test last? And if we're breaking the rule, how often do we break it and why? So here's one example. Second example is from the refactor category. The card talks about code smells, and it says that code smells are indicative of potential issues in software code, pointing to areas that may require refactoring or improvement due to suboptimal design or implementation choices. And it gives some examples, and then it asks some important questions. Does your team have a good nose to detect code smells? Does your team know the right patterns and techniques to refactor these smells? So it's a good question to ask. And yeah, maybe the card will act as a catalyst or a motivation for the team to start learning about code smells and perhaps schedule sessions and stuff like that to learn about this topic. So the last example I have, it's the third card from recommended practices, and it talks about coding katas. And it says that coding katas are practice exercises where developers work on small, focused programming tasks repeatedly. And it continues on, and then it asks 2 questions. Does your team do coding katas collaboratively? And how often do they do them? So yeah, this card basically is going to guide the team towards, we need to start doing coding katas. Coding katas are important. And yeah, you can use the card deck the way you want. Now, there's a card that proposes a couple of ways, but you can use them any way you want. When you're doing lean coffee, in a retrospective, lunch and learn, if you're still learning TDD, these cards are really great and will definitely improve the experience of the team practicing TDD.
Very well done, Ahmed. I like the structures. The questions that are included at the end of every card help teams start discussions and reflect on their experiences. It's also a nice and lightweight tool for teams that dedicate an hour per week or per sprint to discuss these software development principles and practices, as you mentioned in the TDD adoption plan. Thank you, Ahmed, very much for these great answers. If our audiences have any questions, they can start asking them. We have already a few questions. Ahmed, can you go ahead with the first question, please?
Okay, so I'll go ahead with the first question, and we'll wait until our audience asks more questions. and then I'm going to answer the rest of the questions. So we've received a question from Mahmoud Abdelrazak over LinkedIn, and he's asking, should I add all tests for every component of a feature in the same test file? So yeah, this is a very good question. Thank you very much, Mahmoud, for that. So now, when you say the word component, the word component can mean different things depending on your software architecture. Okay, so as you know, there are two ways of partitioning in software architecture. There is technical partitioning and there is domain partitioning. Okay, so if we're doing technical partitioning, when we say component, we're talking about a piece of code that is either in the presentation layer or the API layer, or in the business or service layer, or in the data access layer. Okay, so if this is the type of partitioning that you're doing, then and you're going to follow the classicist school, then you will want to start with the business logic layer first, and then move upwards towards the other layers. Okay, and make sure that you are testing the behavior and not the structure. Okay, this is very important. Okay, and yeah, remember that you're not only going to be doing unit tests, you need to do also component tests, integration tests, and end-to-end tests, and you have to follow TDD for that. Okay, so you write the tests first, and the tests drive your implementation and your design. Of course, if you're following the London school, it's going to go the other way around. So again, if you're doing technical partitioning, you will start from the presentation layer or from the API layer, and then move downwards towards the data access layer. If, of course, when you're testing the data access layer, this is kind of an integration test. Yeah, and make sure that you are not testing structure and you're not testing the library. So for people that are using Spring Data, for example, and you're writing a repository and the repository has no custom codes, you don't have to write a test to test the repository. Why? Because you know that it's going to work. Find one or find all or whatever, these methods are going to work. Okay, but you're still going to be testing that as part of your component tests or system tests or whatever. Okay, because you have to test everything working together. So and people call those large unit tests. So yeah, just be careful that you're not testing something that you know beforehand that it works. I mean, don't test ORM, for example. You know, ORM will work. Okay, the library will work, the framework will work, but what was I saying? Yeah, take care of testing structure, and don't test something that the developers have already tested. Don't test third party. This is not within your scope. It's out of your boundary. Yeah, this is to. I hope this answers your question. So regarding organizing the files, I recommend that each test class tests a user story and has all the test cases for that user story. And don't argue with me about having a large test file, because the user story is supposed to be small and you're not going to have 1,000 test cases. It's going to be a couple of test cases. Okay. So yeah, I hope this answers this question. So Khaled, do we have any questions from the audience?
Yes, Ahmed. Hadi Zainuddin asks, could you explain the difference between test doubles like SPI and versus mocks, and tell us real use cases?
Okay, spies versus mocks. So with spies, you are accessing the real code that you actually want to create a test double for. Okay, but with a mock, you're basically asserting that you have passed across certain lines of code in your production code. So they are both test doubles, but they're different. They're not the same. To be honest, I haven't used mocks ever. I've seen people use them in legacy code, and I wasn't really convinced that they were necessary. Okay, but maybe you're testing some code that is supposed to call the database and the database is still not there, so you just want to make sure that the code that calls the database is going to be called, but you don't really want to call the database. So maybe that's one usage, but why would you want to do that? I haven't used spies outside the scope of a coding kata. Okay, so yeah, maybe you're writing tests for code that is tightly coupled to a certain framework, and you're not able to break the embedded dependencies, and so you have to call the real code from that third-party library or whatever in your test to make it work. This is the way I saw it being used, and again, I personally didn't have to use spies or mocks ever. I've used spies only in coding katas, and mocks I've seen people use them in legacy code that we have inherited from in a certain project that I worked in, but I only use fakes and stubs. And I think Khaled, you because we've worked in the same team. Yeah, we only use fakes and stubs. And when you're using fakes, sometimes you don't have to use a library to implement fakes. It's totally unnecessary. And if you want to use stubs, yeah, maybe this is when you will start using a library. Okay, if necessary. So I hope this answers the question. And thank you, Hadi, for this question.
All right. Do you have any more questions, Ahmed?
Okay, so Hadi has asked. This is a follow-up. So let's put that here. So I know it might be out of scope, but could you explain the difference between test doubles? Like, no, that's actually the yeah, that's the first question. I'm
Yes,
sorry. So how can we measure the interactions in certain objects with fake, like verify interactions in objects? Hadi, I don't really understand the question. So if you can rephrase it or do further elaboration, I would appreciate that. Okay, so until Hadi rephrases the question, maybe we can take the second question by Mahmoud Abdelrazek. So he's saying, when testing the layers of domain-centric architectures, is it correct to test the services and the repositories with stubbed data sources? and just set the stub data source before verifying the expected result, etc. Yeah, sure. Why not? It's totally acceptable, because here's the thing. Of course, again, it all depends on which school you're following. So if you're following the London school, you'll definitely need to stub things. Okay, if you're doing classicist school, then your domain layer or your core is supposed to be framework independent, and it should not know anything about input and output devices. Okay, as Robert Martin has explained. So if you're testing the domain, you shouldn't really be relying on test doubles at all. Now, moving upwards to the use cases, yeah, this is when I think you will need to start doing a little bit of stubbing, because you're going to need to call some repositories, and behind the scenes, these repositories will need to get data from APIs or data stores or whatever, and you'll definitely need to use test doubles for that. And yeah, when you move to the services layer, I'm not sure. Again, it depends on the type of domain-centric architecture that you're following. So if you're doing clean architecture, there is no service layer. I think you're referring to the outer layer where you may be exposing REST endpoints or something. So I don't think you will need to do any stubs if you're doing classicist school, because you will have already implemented the use cases and the entities or the entity layer in the clean architecture. And so all the inner layers are there. So why would you want to stub anything at the level of the REST endpoint layer? So that really depends on my understanding. But if you're doing onion architecture, so you have application services and you have domain services, yeah, again, if you're doing classes school, you'll not need to do stubbing. But if you're doing mock school, yeah, definitely you will need to do stubbing and perhaps mocks as well. Okay, so Hadi has rephrased his question, so it's a bit long. So this example, okay. So Hadi, I think since your example has code in it, so maybe we can take that offline. Feel free to message me on LinkedIn or Khaled with your example, and we can answer the question, okay? Because there's code and it's a bit unreadable, okay, to the audience, okay? So sorry for that, but we can definitely take your question offline. So we have Muhammad Abdul Khalid. He's saying, when I do integration test and mocking test, okay, or even the mock test is useful in terms of I mock everything except the function I test, of course. Well, I'm not sure I understand the question. Muhammad, maybe you can rephrase it. If you want to write it in Arabic, yeah, why not? So yeah, but I don't know. I'm having trouble understanding the questions today. So Khaled, can you, if you understood the question, maybe you can explain it to me. But here's one thing. Sorry, Khaled. Okay, so let's talk about integration tests. Okay, So integration tests are a type of tests where now there are different understandings. Now I'm going to explain it from the perspective of microservice test strategies. In integration testing, you're basically testing the component in your code that integrates with a messaging queue, a database, another microservice, another service, whatever. Okay, so you're testing that code, okay, that basically integrates with something. Okay, so yeah, maybe if you wanna write unit tests for that code, so maybe you will start first with mocks, and then you will do the actual implementation of the database or whatever, and then you're going to do integration testing against the database or against the web service, whatever. Take care that when you're doing integration testing, if you're using test doubles, it's not really an integration test. So you can use mocking just to, you know, get the test at least going green. Okay, that's the way I think I can think about it right now. But take care that an integration test is not really an integration test if it's going to use test doubles. Okay, because you want to make sure that the component that is integrating with a third-party library or a database or whatever is really working integrated with that detail, database, queue, API, external API, whatever. So I hope this answers your question, Mohammed.
Ahmed, going back to Hadi's follow-up, I think he asks about in mocking, using mocking in TDD, we verify certain interactions between the class under test and its dependencies. Now he's asking, how can we verify such interactions with fakes? But the thing is, I think with fakes, we don't verify interactions between classes and their dependencies. We verify in the output, in the result of the function under test or the class under test. Do you have more thoughts about this?
Well, here's the thing about mocks, okay, is that when and correct me if I'm wrong, Khaled. So in Mockito, okay, you are asserting that your code has ran across a number of statements. Okay, so certain statements in the code have been called. Okay, this is how you do mocking. Okay, so I'm not really sure what you mean by interactions. Okay, but it's you're making sure that the code behaves as it should by moving across certain parts of its structure. Okay, this is what mocking is all about. So if this translates to testing interactions, fine. But to me, and I agree with Khalid on that, it's not testing interactions, because interactions are structure based. It's interaction between parts of code and the other. This is structure, and you're not testing structure. TDD is supposed to be behavioral driven. You're testing behavior and not structure. So no, the tests are not supposed to test interaction. But yeah, the thing with mocks is that you're testing behavior through testing structure, which is the downside of it. So I hope this answers your question, Hadi. And again, feel free to get in touch with me or Khaled, and yeah, we'll be happy to answer your question.
Okay, I think we can move on. Ahmed, would you like to reveal our upcoming TDD workshops and promo codes?
Sure. So here's our first announcement, and yeah, I'd like to thank people who have waited around until they reach that part. So whether you're watching the recording or live, so we're going to be delivering a test-driven development fundamentals workshop, online workshop, me and Khaled, on November 11th. Registration is open, and you can scan the QR in front of you. And let me put that on full screen. And yeah, book a place. The seats are limited, and when you access the website, you're going to find all the details you need about the workshop. We have done 3 workshops so far, and the feedback from our students was really good. And yeah, it's definitely something that we recommend that you register for if you want to start your TDD learning journey. We have another announcement. The long-awaited advanced TDD course is finally out. It's a new course, and it takes your TDD learning journey to another level. We're going to teach you a lot of advanced concepts in TDD. So this includes how to deal with test loss, dealing with legacy code, mutation testing, code coverage, and many other topics. And like as is the case with the fundamentals course, we're going to be working hands-on on little exercises to explain the concepts, and then in a big kata that will act as a capstone project. So seats are limited. Don't miss out. Register today, and you'll find all of the details in the QR. And yeah, if you have watched this video, we are happy to announce that there is a promo code with a 10% discount. So if you're registering to either courses, just enter this promo code in the registration form, and you will get 10% off either courses. Okay. So yeah, make sure that you make use of the promo code. So last but not least, we've announced that we are offering 3 free guided workshops with the TDD cards to teams that practice test-driven development. So if you're an agile team and you want to experience using the TDD cards, you can book a free guided workshop with me and Khaled. We are offering 3 workshops for only 3 teams. And so if we get many registrations, obviously we're going to be selecting only 3 teams out of the many teams that are going to register. So don't miss out. Register today while it's still free. And yeah, take your TDD experience to the next level and see how TDD cards can improve your TDD experience. So there you have it. You have the free TDD cards guided workshop. You have the advanced course, and you have the fundamental course coming up in November. And yeah, as we've said, use the promo code to get a 10% discount.
Yes, Ahmed. If anyone finds anything that we talked about here interesting, they can, and they want to learn more about it, they can definitely join the courses. Thank you, Ahmed, for this brilliant session. It's been a pleasure talking to you. I would also like to thank all our followers and attendees. Please follow Tech Cafe on LinkedIn and YouTube to get our latest updates and to check out our coming sessions. Thank you all, and until we see you next time.
Thank you very much, Khaled, and thanks to our audience. See you in coming sessions.
See you.